A very warm welcome to Augspoon, your technical magazine with Wolfgang Rudolph. Hello, coffee in the morning is very important for me, but when something happens like today, that the coffee machine breaks, simply out of the blue, that is awful. You can handle that, you can make coffee differently, like we used to make it. But what happens in your firm when a machine during an important order which has to be produced simply breaks down? What happens when you drive on holidays and your car just suddenly stops and has to go into the garage? What happens when you drive to a customer with a special order and the machine or the car or whatever breaks down? Condition monitoring, that means a state control of machines. A little like looking into the future. And how is the status of the machine? And how you can do this nowadays is a difficult thing. I will try to explain that. So naturally, you can build into machines lots of sensors, and these sensors monitor the condition of the machine. That means vibrations, temperatures, different burdens, power consumption. As you probably know, when a fridge breaks down, it usually uses more electricity before. If you had then a monitoring, you would know that it would eventually break down, and then you can react to it. The repair time can be moved into times when no important orders are waiting. But that is at the moment in lots of firms not the case, because we make preventive maintenance. For example, when a tyre is worn, it has to be renewed, but we don't know how it looks like with spark plugs or air filters. That is always changed standardly, even if it doesn't have to be changed. That means we are throwing money away, and in firms where large machines are preventively maintained, and although parts are changed even if they aren't broken, there's lots of money thrown away. When we have the possibility to monitor a machine continually, or even from time to time when we want to daily or weekly or whatever, and then from the results read out, recognize when something's going to break, and say good, we have to do that and plan it. We would then save lots of money, because we are not renewing parts which haven't to be renewed. And it doesn't come to unexpected fallout time, continual monitoring, that is a theme. There are also a lot of devices, not only built-in sensors, but also external devices, which you can use to look ahead and recognize repairs and to do them. Revolutions is very important. We have many areas where we have to know how fast a shaft turns, and that is simple to do. For this there are measuring devices. I have here a speedometer from PCE, the DT66 is what it is called, and it has a very large measuring area, from 50 revolutions per minute to 19,990. And the crazy fact is, in the small area, a resolution of 0.01 revolutions per minute. You have to imagine that. So an amazing thing. So now I'll turn it on so that we can see the display. First of all, it makes a self-test, and now we can see in the display stands RPM. That means revolutions per minute. I can also switch over to others, for example to 5 different values, for example here set points. That means I can directly measure speeds, and to have this you need a definite translation. As accessories which is delivered directly with it, different wheels, set wheels for example, 10 cm diameter or that you get metric measurements straight away, different attachments, an extension if I have to go into something, where I can go into the deepness of a machine to measure. So how that works is very easy. I have revolutions per minute set. Now I have to start my machine. I have a little motor here, and that you can see that it turns. I have stuck something onto it. So now wait, and I push onto measuring, So, and now you can see we have about 150 revolutions here per minute. With my toy here, naturally it isn't very exact, there is a little slip there. So in these values, when I let go, they stay saved, and I can now call them up. Minimal revolution, maximal revolution, and so forth. I can also save the values in the memory and read them out later. So let's take that out. So a simple possibility for revolutions. Number of revolutions or speed of conveyor belts to measure with different adapter sets which are simply put on top, and that's all. So what you can see is my model of a Stirling motor, which is run with warm air, and I have here the TC-31, a thermal imaging camera. I want to see how the heat here is dispersed. I will just let you watch with me. When you see here, you can see at the bottom there is the flame. It is naturally very light, and more above there is the cylinder. And then the camera has to recalibrate. A new color table is newly defined. And when we blow it out, it glows a little further, because there is still heat in. Now it stops, and you can see how the temperature, I'll hold it slanted so I can aim better. There the heat from the wick goes steadily down. The cross in the middle, that is the point, the measuring point. Now when I go onto the pistons up here, it looks relatively dark there. And when I now go onto the side, it is hard to see. There you can see the dispersal of the warmth from the cylinder to the front to the pistons. Over here it changes a lot. Why, I will show you that. Okay, that is a toy. But when you have big machines, that it is possible with a thermal imaging camera the heat to measure. To see that what your eyes can't see. For example, we can see with this if a bearing has got too warm. We can see with this if on any position a leak has begun in pipes. We can also measure electrical cables with it, measure, monitor, even through the wall with it. When they're overloaded, strongly overloaded, everywhere where heat builds. So now with this micro bolometer, which is built in here, a sensor, you can also, I'll go here to the menus. You can call up different menus, call up settings. I can different emission grades call up. I can choose different color palettes and so forth. So an extensive measuring program is possible with it. And when you save the data extra onto a memory card, here's by the way the USB connection. With this I can attach it to a PC and charge it up, or fit the memory card onto it, and I can record videos and also pictures. Depending what I want, I just pull the trigger, record it and finish. What I can do with that, there is a software delivered with it, and when you look at what that looks like, we have here a standard picture. You can see this ribbon formed structure, and the software is capable to convert this picture into 3D. And when you look at that, that is pretty impressive. You can also, with the software, turn it. You can basically see on which point what temperature is. And later I can still measure temperature even though the device which I measured isn't there anymore.
Gar nicht mehr da ist.
I have here something very special. An endoscope camera, the VE 500 from PCE. A camera which you can use in a professional area. It has a stable casing and rubber grips. I've seen in car garages when cavity sealants are proven, then they put this 2-meter long tube into them, and on the end of it there is a camera. You can also turn on the LED lighting. Set the bright and dull so that you can see even in the darkest corners. So the camera itself has a power pack so that you are very mobile with it. The pictures you can record and also you can make videos with it. There are great big operating buttons for that. Delivered with it is a 4 GB memory card and deflecting mirrors. I have left them in their casings because I always get my fingerprints on them. There's also a cleaning set for them with it. Here you have though deflecting mirrors for if you want to look into any sort of corner. When you don't get there with the tube, the bending radius should not be smaller than 15 millimeters. That's obvious, you shouldn't kink it. And it's not only for technique, not only for machines, for prevention maintenance. I thought a bird watcher could, without disturbing his birds, simply have a look at how it looks like in there. And then I have a bird's house. And put it in here. And now when we look at the screen, when I do it properly, then we can see there the bird sits. It is naturally not a real one, so I just wanted to show you there are unbelievably lots of possibilities. Once naturally to save money, and naturally to look there where I can't get to with my eye to look, or in other areas like hobby areas. I have seen one with a model railway, where they look into a tunnel or somewhere underneath the board. So here's the bird. When we say okay, that is a bit complicated, a bit difficult, we can take off the camera part. There's a power pack in it, like here. They can be used together or apart, and as you can see the picture runs on. Why? Because they run over a 2.4 GHz radio wave, which is automatically connected when separated. And now when I try to record pictures, you can see them naturally even though there is no direct connection. We can, like before, make photos, videos, also a live picture over the delivered connection cable, directly onto a large display, a TV or the sort. An ideal device for endless possibilities, mainly for the usage in the industry or commercial area, for prevention maintenance to look if anything is broken or if everything is okay. Not to be surprised when suddenly something does break. Now I have here something very difficult. Even to explain it is very difficult, but we will try. When you join machines together using shafts, that means a motor with a generator for example, then they must be exactly aligned with each other. When we have a look at that in the graph, we see there are two different types of errors. For one, a high offset, we can see that in the one graph, and in the next graph we can see that we have an angle offset. That means it can be bent or even go to the side away. And when you try to join the machines with force, even if there's only a minimum offset, then it causes strong strain to the bearings and even to the joint. And then an early wear. That is why it is totally important with high precision that such machines are aligned to each other before. They are really joined tightly together. And for this we have here the PCE-TU 3, a device with an unbelievable function variety. Well, I haven't got through everything yet because the handbook alone has 95 pages. And naturally I have to understand them all. But when we have a look at it, we can see there's a keyboard and a lot of function keys. And the display, it shows me something already. There are two blocks, and in these blocks are little red circles. These little circles, when you look at the display, the right one has wandered, now it is outside of the picture, and then a signal blinks. Now it is coming back. How did it do that? I can show you that now. And on this PCE-TU 3 are two laser sensors. That means that here a laser sensor is sent out and from the other sensor received. and the other sensor sends exactly the same, and the first one receives it again. The received beam isn't only there, is something, but down here there is a built-in, a positive sensitive photodiode in the size of 10 times 10 millimeters. That means it sees what location the beam is received. So all I have to do is attach these two parts onto the parts which have to be aligned, and when my arm was the shaft, it goes like this onto it. And on the top, one of the sensors is put on, and they are tightened with this delivered chain. They come onto here and are wrapped around the shaft and tightened up. There are also fastening materials so that the sensor are securely attached. They shouldn't be able to slip or wobble. Why? Because the resolution of the device is by 1,000th of a millimeter, and with an angle resolution of 0.1 degrees. Incredibly precise. For this you must naturally know how far the two sensors are apart. When we look at that on the graph, we can see that the generator and the motor have an offset in the horizontal. That I must know, and we also have the angle offset. And the distance they have from each other goes into the calculation. There's also a measuring tape with it. All this data I must tell the device beforehand. And then it gives me definite correction instructions. Until the parts are highly precise set to each other, so that they run perfectly and possibly without an early wear. As I said, the complexity, everything we can do with it, is unbelievably large, even though the operating is very easy. As you can see yourself, you look at it and align things averagely and then start to measure. The machine, generator, whatever the movable part is, the other must be fixed, they can't both move, and then be aligned. Naturally you can save all this data onto a memory card, naturally you can save everything on the computer, connection cable is delivered with it, it is also powered with a power pack, so that you are independent of a socket. A measuring device of the absolute top class, and I think I will be a few days working with it because it is not only good but interesting. So, all of our four devices at once. Let's start on this side is a revolution measurer. The DT66, revolutions from 50 RPM up to 19,999 RPM with a resolution of 0.01 RPM. Then we have here the thermal imager, the TC31 from PCE. This thermal imager, you can see me in it at the moment. It can from -50 to 350 degrees resolution. Saves pictures, saves videos, they can be read out later, it has a high value software with it, with which you can look at the pictures later in 3D. Very impressive by the way. Then the endoscope camera, the VE500, a camera with a 2 meter tube which has a diameter of 5.5 millimeter and which you can detach. The display from the device detached to operate, then with radio waves connected, both with their own power pack, which can be alone or together be loaded. Here also the usage of a memory card to save pictures and videos, and an absolutely top device, the TU3, a laser-based shaft alignment device with two external sensors, an exactness of 1,000th of a millimeter, and with 0.1 degrees angle. So devices where they can be used everywhere for preventive or early detection of possible machine breakdowns, as well as in other areas. Goodbye.